Graphing and understanding how to graph is an important skill. Not only do you need to use it in school and things like the ACT, P.S. the science portion of the ACT is mostly just interpreting graphs and stuff. But as you get older, they're going to be in newspapers and on commercials, and you need to be able to know again how to make them and understand them. So we're going to start with a line graph first. If you feel comfortable with this and you just want to make it and then compare it to mine, feel free. Otherwise, stick with me and we'll do this together. So, over here we have a box of information. In 2000, a law was passed against the use of cell phones while driving in any town, New York. Since then, the number of people who use cell phones while driving in any town has changed each year, as shown in the table below. Construct a line graph to visually display this data. So, my first step for making a graph is always to give a title that if somebody were to pick it up, they'd know exactly what the graph is about. It's a quick way to understand what's going on. So I'm going to look at my data table over here and see what my data is about. Well, it's the year and the number of people using their cell phones while driving. So think of a good title. I'm going to kind of pause the video here, let you write down a title, and then you can compare it to mine when you're done. I took the title directly from the table there. I said cell phone use while driving in any town, New York. So it's going to be clear to whoever's looking at this graph exactly what's going on. The next step is to figure out what's my x and y, and then label those axes with a unit when appropriate. So remember, on the x, the side-to-side horizontal, is what I can change, and the y is what I am measuring. So between the year and the number of people who are driving with their cell phones, which can I control? Can I control the year, the time when I measure? Or can I control how many people are actually driving on using their cell phones? Well, I cannot control who's driving using their cell phone, obviously. But I can control, do I measure every year, twice a year, every other year? So that's going to go on my x-axis. So let's label that right now as year. And then on my y, I said that's going to be the number of people. And I'm going to use the number symbol because it's a little bit tough for me to write on my computer here. All right. For the year now, I need to orient, label, and now I need to scale correctly to use my space. I don't like it when the graph is scrunched into one little corner because you cannot see what's actually happening with the data very well. So my years, I have from 2000 to 2007. How many boxes do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Obviously, I don't want to start with year 0. That just doesn't make sense because 2000 would not be easy to see. So my first thought is I'm going to do this little squiggly line, and that little squiggle means I'm cutting numbers, and I'm going to put year 2000 right here. So I'm saying I'm cutting from year 0 to year 2000, and then I'm going to label over 2001, 2002. Go ahead and pause me if you need to, because through editing magic, it's going to be done in a split second. There we go. So I actually went all the way over to 2009 just because it's good to label the entire axis. I know we don't have data for 2009, but I would still like you to put in data labels for 2008 and 2009. All right, going up the y. So my lowest number is 192, and that was a terrible circle. My highest number is 309. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 boxes going up. If I were to, let's say, start at 0 and go up by tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 20, 30, 40, 50, I'm not going to get up to the number that I need. So I thought about this beforehand. I said, well, what if I do the squiggle here, meaning, remember, I'm skipping from 0 to some number, and why don't I start with 190, because that's just a little bit below my lowest, 190, and I go up by tens. 200, 210, 220, magic. So my highest number is 309. This definitely accommodates 309. And then, like I said, I still label up the rest of the way. My last thing is to plot my points. So I'm going to start with year 2000 and 309 people. So here's 2000. I'm going to go up to about 309. Well, here's 300, here's 310. So 309 is just a little bit before it. My computer is not the most cooperative, so bear with my awful dots. It would actually be nice to have it a little higher, but that's all it's allowing me to do right now. 2001, and I have 274. So about halfway would be 275, so a little bit down from there would be 274. And I just figured out that if I try and make a circle, it erases my mark, so I'm going to do little dashes like that just so it stays in place. I want you to finish up the rest of the data, and then mine will be done when you're ready to come back and you can compare and see how you did if you got it right. All right. Now, because this is a line graph, we need to connect our dots. So if you haven't done so already, make a line that connects all of your points. Again, I apologize for how terrible this is. Really bad. On the computer, you would ideally use a ruler or a straight edge if you could. Oh, this is terrible. Ignore this line. That one means nothing. But you can see a general trend in the data. Now, if I ask you to analyze this to explain what's going on, what would you say? Well, I'm looking at it, and I know, again, it's the number of people on the year of people using their cell phones while they drive. So I would say that from 2000 to 2004, the number of people driving and using their cell phones decreased drastically. However, there was a little bit of an increase within the next year, and then from there, it continued to decline. So you're just looking for patterns in what's going on. Next, we're going to do a bar graph following the same rules, and hopefully this one is a little bit easier, especially if you found that first one difficult. I think most people find bar graphs simpler. So we need a title. This is favorite color and number of students, so I'm going to call this the favorite color of students. It would be nice if we could be more specific and talk about, the number of students in 5th grade or whatever, but this is the only information we're given, so we're just going to have to work with it. And I forgot to mention again, if you feel comfortable with graphing, just go right ahead of me and check your answer at the end. If not, stick with me. Next, I need to orient my axes correctly. What goes on the X, what goes on the Y, and step 3, label them. Can I control the colors that I ask about? So again, I'm asking what I can change. I should say change, not change. So what can I control? Can I control students' favorite color, or can I control how many students like that color? Well, if your favorite color is blue, I can't change your mind, maybe, about that. So what I can control is what colors I ask. I can ask red, green, yellow, blue, purple, orange. I can change the colors. It's up to me which colors I'm asking. So this would be favorite color, because on the X is what you change. And then on the Y is the number of students. Next, we're going to scale. And again, I have 10 boxes. I remember that from before, and I have 5 colors. Now, I like spreading out my data. So I am actually, for every 2 boxes, going to make that 1 color. So for instance, from here to here is going to be red. From here to here will be green. From here to here is going to be yellow. From here to here is blue, and from here to here is purple. Now notice for a bar graph, we're kind of going between the lines and putting information in there, whereas with the line graph, we're putting them exactly on the lines. Okay, now I want you to figure out a scale going up the y-axis. Make sure to spread out your data as much as possible. Take into account that our low number is 19 and our highest number is 55. It's okay if you scale it a little bit differently than I'm going to, but I would at least give it a thought. Think about it, come back and see what I do. Here was my thought. I wanted to spread out the information as much as possible. Yeah, I could have skipped maybe up to 15, but then my numbers would go up above 60. If I was going by 5s, I'd be up in the 70s. And I just figured, I'd like to get the bars up to the top as close as possible and use my space. So I started at 0 and went by 5s. So I'm going to actually switch my color here. Hopefully this cooperates. So how many students like red? Well, I know that there's 19 students, so I'm going to go up to 19 there and make my bar. How many students like green? I have 55 students, so green is pretty popular. Go all the way up, and again, ideal to use a straight edge, not as cooperative as you can see on my computer. How many students like yellow? I have 43, so not quite 45. It's probably about halfway or so in between, like so. And you could put a line down the left side. It's just hard for me to draw in here, so I'm kind of skipping that part. Blue, we have 48, so higher than 45, but less than 50. There we go. Ooh, that was a bad line. And lastly, we have purple. So how many students like purple? I have 35. That should be right up on that line. You could color it in if you like, but again, that's just the general way to go about making a graph. Pretty simple. If I asked you to interpret it, we have that data table. It kind of shows the same thing, that we know that there's more students who like green, the fewest number of students like red. All right, next, analyzing and interpreting data. So this one says, which Simpson is which point on the graph? So I need you to figure out, here we have this graph and here we have the Simpsons. Who is who? Down at the bottom, so whenever you get a new graph, read the title, read the axes, use it to help you figure out what's going on. I know that this is about the Simpsons. I'm looking at their age in years, so how old they are. Youngest is on the left, oldest is on the right, and then how tall they are in centimeters going up the y-axis. So Bart, if you don't know who Bart is, they kind of give you a little hint. It's the little boy. So here's Bart Simpson, and we need to figure out which point is he on the graph. So if this was me working through this problem, I'd say, okay, we have 3 young people on the graph, so under 20. So we're going to be looking in this section of the data. Now I have 3 points, and remember, we're going by height. So this dot right here, almost a year old, maybe a year old, very short. Here we have 2 that are about almost the same age, but one's a little bit taller than the other. So how do I figure out who's Bart? Well, I would say between Bart and Lisa, if I look at how tall they are, that's not a straight line by any means, but Bart is a little bit taller. So knowing that, I would say this point is Bart, this point is Lisa, and then this point is Maggie. So Maggie's the baby sister, Lisa's the sister, Bart's the boy. Please figure out who, so this is Abraham, Grandpa. This is Marge, and you're ignoring her hair because her hair is very tall. This is Homer, and then this is Mr. Burns. Figure out who is who on the graph, and then I'll give you the answers in a little bit, but I want you to try and figure it out first. All right, I knew that Marge and Homer were the next oldest, and I looked at the 2 dots and I said, well, Homer's a little bit taller, so he has to be this older dot. Marge is the lower dot. And then Abraham and Mr. Burns are the 2 oldest, and Mr. Burns is definitely shorter than Abraham, so I said this is Abraham up here, and this is Mr. Burns. So this is just an example of data interpretation, something that you should be able to do. You're going to work a little more on data interpretation. So that was the watch part of the whisk. Here comes your summary and your question. It says, for the summary part of this video, complete the following exercise. Be prepared to discuss it with your table group when we review the video. So tomorrow you'll be discussing this with your group to see how you did. You have each of the graphs and they match a statement that's in the middle, and the statements are about the y-axis, the vertical axis. The graphs show the number of people against their ages. So first you need to figure out which graph goes with which statement. And it's all listed off to the right here. So which graph A through D shows number 1? A hint is to look at the age and think about what's going on. So for example, if you look at graph C, a lot of people between like their 20s and 40s have a job, but then fewer people in their 80s have a job. If you're looking at graph D, they're showing that everybody, the same amount of people, about from 20 to 80, have a job that's full-time. Think about all 4 graphs, that's just 2 examples there, and figure out which one it is. For next one, it says, which graph shows the number of people who are left-handed? So which of these graphs would accurately represent, or hypothetically represent, how many people are left-handed? How about the number of people who wear glasses? And then which shows the number of people who play for a tennis team? Try your best. If you're stuck, that's okay. Ask for help from either a friend or from me, and then we'll work on it more in class tomorrow. And then at the end, come up with a question. You'll do this with every single video that you watch for me. It needs to be something you're confused about or something to discuss. So if you're confused, circle confusion and then write a question to help tell me what you're confused about. So how do I know which is the x-axis? How do I know which thing should be my title? Something like that. If you're not confused, you're going to make a discussion question. So when we talk about the video in your table tomorrow, then you can talk about it. You have something to promote conversation. So you could be sitting there and say, how do you know which axis is the x-axis? It doesn't mean that you don't know the answer. It's just getting your table to review what you saw in the video. So come see me if you have questions. Let me know if you need help. Please, please, please ask. And if not, then we'll see you later. Good luck.